So in part two, we're going to talk primarily about data normalization, and this is the process of creating, as it says, table designs by assigning specific fields or attributes to each table in a database. What we try to do by normalizing the database is get rid of any redundancy, any inefficiency within a table. For example, we wouldn't want a table of orders that had redundant parts, for example, or redundant parts of descriptions. We would want to create a unique part number that could be referenced on an order, and then the description of that part be in a separate table where it's stored only one time. And this can be a real challenge to do. This is a real art form. So just hold on and try to get out of it what you can. There's also videos that you can find on YouTube to reiterate this concept that we're talking about. So basically the stages are unnormalized design, first normal form, second and third, and we'll talk about that. And ultimately, we want to get our database to third normal form, which gets rid of all the redundancy. Every field within a table has a direct reliance or a direct relationship to the primary key, and you'll see what I mean by direct as we go through this. So we start out with standard notation form. This is how we would note, a table and then each field identifier, within a series or a sequence. So the repeating group is a set of one or more fields, like I said, that can occur any number of times in a single record, and we'll see an example of that right here. So here we have, in unnormalized form, an order table, and as you can see, there's going to be redundancy within the order number. There's going to be redundancy within the date. We're also, by the way, we might find some redundancy, for example, in order 86390. We're going to see some redundancy in the supplier. So we can see that we have the opportunity to break this down into many tables, getting rid of that redundancy. So as it says, two orders have repeating groups. They do. That contains several products. They do. Order is the primary key for the order table, and product number serves as the primary key for the repeating group, because we can see, the repeating group. So let's take this into first normal form. So in first normal form, okay, we get rid of those repeating groups that we saw. Okay, we eliminate the repeating group in the record. So let's take a look back at our example and see how we did that. So here, we now create a unique primary key based on the combination of order and product. So we get a primary key for this specific record. There is no repeating those two items. We know that in our rules, the rules of processing, any one order is going to have one product number. Now, that doesn't mean we can't order, as you can see, a quantity, but we're never going to list on an order the same product number twice. Okay, so that comes from our business process. It gets applied, and here we apply it to first normal form to create that unique entity for the record. We get rid of, notice there are no repeating groups. We don't have a repeating group because the combined primary key will be unique for each record. So that moves us to second normal form, and it says, field A, it's just a field, is functionally dependent on field B if field A depends on field B. We'll see what this means. Date, for example, is a great example where never will we have the same order on two separate dates, right? So date is functionally dependent on an order number, for example, okay? So in second normal form, we break apart that table that we had, okay, that still had some redundancy. We create an order table. It lists the order. It lists the date, okay? If you notice, there's no redundancy here. Then we have the products, okay? So now we've taken, and we're not going to have redundancy in product because in a separate table, one product will only be listed one time. Now we'll see that we have an opportunity here because we still have redundancy. So again, don't overthink this. Just look for things that are redundant and see how we can break this down. We'll do that in third normal form to create another table. So Order and product create an order line. Okay, so they're combined together. They're joined with a table that has the order line. The order line becomes unique because all of the information is dependent on this primary key, this combined primary key that we created. The quantity is dependent. So you see there's no redundancy at this level. We do find redundancy in this table, so we need to take care of it. And we do that in third normal form. So a third normal form design, if every non-key field, which means every attribute that's associated with that key, that is part of that key, that is in relationship with that key, only depends on the key, no redundancy. That's basically what all of this stuff here is saying. So let's take a look at that product. We're going to break it out to two different tables. Okay, so that we get rid of this redundancy, we have a supplier number. We're going to create a table with a unique supplier number, the supply, and then the product. So one product, in this case, is going to have one supplier number. The two become the key, the supplier number becomes part of the key in the product, and we get rid of that redundancy. We have all the data. Notice all the data is still contained. It's just instead of having Acme listed 50,000 times within this product table, it's listed by its key, its associated, and all the subsequent data that relates to the supplier number. Supplier name, of course, we'd have a lot more information. Address, contact, contract date, all of that stuff would be included in that third normal form of the supplier table. So here's a real sort of a real world example. One advisor advises many students. There's our entity relationship diagram. The student can take many classes. Many classes can have many students, and many students can be advised by one advisor. So you get the idea. So we start out in unnormalized form. We see we have the redundancy in the groups. A lot of redundancy here. Students, student number, student name, GPA, all that good stuff. So let's take this out to first normal form. So in first normal form, we create that unique identity by finding things that will be unique. The student number in combination with the course number creates a unique key for each record in here. Okay, so that becomes in first normal form. Now we need to get rid of second normal form by reducing or breaking up this table into something that would represent the student and the student specific information, and then the class, and then of course we deal with the advisor in third normal form. So in second normal form, we've broken it out into two tables. We see that now the student number, everything related to the student is in there. The course is in second normal form because the course and the number of credits, of course, we'd have course description and etc. Okay, so we don't have that redundancy here. We're still going to need to deal with the redundancy in the advisor name, and we'll do that by, again, separating this student table, as we'll see, so that we just have the advisor number listed. Okay. So, grade in second normal form. So here we have a primary key based on the student and the course, just like we did, and the grade. So we explode it one more time. Notice going back to the student, we're going to get rid of the redundancy in advisor. We're just going to have the advisor number. We are going to have redundancy here because remember, one advisor can advise many students. So there's just simply no way to get rid of this because it's part of our business rules. But if you notice, by getting rid of the advisor, getting rid of the office, this redundancy goes away. We have all that information stored one time in our database. So here's that entity relationship diagram. Advisor advises many students, receives many grades, etc. So you can go through this and sort of get an idea, of example 2. So we're taking this into Access, utilizing a relational database Access to kind of give us a look at. You see we've broken down the labor code. The labor code can be part of many service labor details, service parts detail. Notice parts. So again, we're breaking this down. We're normalizing the data so that we don't have the redundancy up here in service parts detail of many part descriptions that are the same, many costs that are the same, many prices that are the same, the quantity on hand. All that stuff is stored one time because it's associated with, say, an object called parts. So I would encourage you to stop and just look through how this relationship works, what the referential integrity is in regards to this. So back to exploding so you can see more of the detail. Here is that ERD from the previous. Okay, so this is the relationships. We explode the relationships and we can start seeing the data inside the relationships. So again, go ahead and pause and take a peek at this. So that brings us up to working with a relational database. I'm going to go ahead and cover the rest of this in the last part of this lecture.